Okay, here are the answers to the Cheltenham 2013 scholarship exam paper. We start with section A, and now it's important to get through section A quickly but accurately. Note also that in the first question they say you must show all your working, so it's worthwhile just putting in an extra line just in case you need to. 1A, make sure you've got common denominators and you get a negative tenth as a fraction. B, just cross cancel and you get a half. C, now this is where you need to be careful. Put it into an improper fraction first, then when you're dividing by a fraction you flip the second one and you find that they cross cancel nicely and you're left with 7/10. And in section part D, just write it out, 2/3 times 2/3, which will show you that clearly it is 4/9 as the answer. For question 2, this is really just a case of remembering your simplifying rules. 7F for number A, for part A. MN and NM, well, they aren't actually in the same order this time. I've seen it where they've done MN plus NM. Remember that multiplication is commutative, so the order of the variables doesn't matter in this case, but here just collect like terms and you've got 2MN plus M plus N. And then C is just a case of multiplying 22 by 11 correctly. Either you know the trick, which is to put the 2 and the 2 and then add them together to get 4, or do 11 squared times 2, or just do a bit of long multiplying. Or in your head, of course. It's 242g squared. Part D, again, just write it out in full, and it's, don't forget your indices, 8h cubed. And then part E, 3 markers, so somebody should be telling you that you need a bit more working for this one. Get a common denominator, which in this case is 2f, and then you get f squared plus 4 over 2f. In question 3, you should see this in any scholarship paper. If you see solve the equations, you should be looking to get full marks on this, absolutely. A is x is 53, you don't need too much working out for that one. Section B, get rid of the denominator by multiplying both sides by 7. Get your numbers on the right, and then x is 12. For a 3 marker, it's worth checking. 2 times 12 is 24, minus 3 is 21, divided by 7 is 3. So it's well worth checking for 3 marks there. C, again, multiplied by the lowest common multiple, which is 4. Cancel the 4 with these two, and then cancel 4 here, and you end up with 6x plus 2 equals 3, minus the 2, and then divide by 6, so x is a sixth. You could also add the 2 fractions here and make them over a common denominator, a denominator of 4, and then you know that the top lines will be equal, but either way is fine. Part D, so this one's only worth 2 marks, but multiply both sides by 3 minus x. Don't forget to put in brackets here, so you remember to multiply both terms by 4. Multiply the brackets, and x is 2.5. Again, it could be worth just quickly checking. 3 minus 2.5 is a half. 2 divided by a half is 4. And in E, again, only 2 marks for this one. So multiply both sides by the denominator. 0 times that is obviously 0. Sort it out, and x is 1. Question 4 is area. Just multiply your 2 meters squared to get 120,000 meters squared. Whenever it asks you to do change the units, you're always well worth going back to the original measurements, changing them, and then working out again, rather than trying to be clever, making meters squared into centimeters squared, or if it's a volume 1, meters cubed into centimeters cubed. Go back to the original dimensions and change those. So you get 30,000 times 40,000, which is this big long number, 1,200,000,000 centimetres squared. I put it in standard form as well, bit of showing off, but you catch the eye if you do something like that. Part C, 5 marks for this, so again well worth taking your time getting it right. It's not actually a very long question. So he's run around the perimeter, so you work out pretty quickly the perimeter is 1,400 metres there, divided by 5, which is his speed. It's 280 seconds, which then, if you read the question carefully, you've got to make into minutes, which is 4 minutes and 40 seconds. In D, A to B, and then takes a shortcut to D, and then back to A. So the first thing you need to do is work out that BD using Pythagoras is 500 metres. You can either run it through like this, or you can use your Pythagorean triplet, a 3, 4, 5, and the multiples thereof to work out this 300, 400, and 500 across. So his total distance is 1,200 metres, which is 240 seconds. Compare it to part C, and you see he saves 40 seconds by taking the shortcut. Question 5 is simultaneous equations. Again, this should be a real banker for all of you. See those simultaneous equations and work them out. And do not forget to check at the end. 4 marks for this one. Manipulate your equations. I did it by multiplying equation 2 by 2. Rewrite them. This way your style comes in. Relabel them 3 and 4. 3 minus 4. Be careful with negatives, because 3y minus negative 8y is 11y. 32 minus negative 78, if you add them, is 110. So y is 10. Substitute into number 1, which is the easiest one to do, and you get x is 1. And do not forget to check it with equation 2. 1 minus 40 is minus 39. Question 6 is about percentages. So you can either do this by writing it out, 30% of that, or do 10% and then 30% is 750. If you increase it by 10%, you need 110% of it, or just find out 10% and add that on. What number increased by 13% equals the original number? You can either do this logically and think that if you increase the number and it's still the same, then the increase must be 0, therefore the number must be 0. Or 113% of x is x, and then you can work out that x is 0 from that. So that's the only number that works. And then what number do I have to increase by 25% to get 300? So decrease by 25%. So the decrease is 75%. 75% of something is 300. So divide by 75 over 100. So you flip it in times, and then work it out, cross cancel, and x is 400. I would suggest that you would need some sort of working to get 2 marks, given that they say show you working. But there's no reason why you couldn't say 400 minus a quarter is 300. Question 7 is another percentage one, but a bit of logic here as well. 30% of 30 is 9 people. 10% of 30 is 3 people. B, the maximum possible percentage who are both left-handed and love maths. Basically, if everyone who loves maths is left-handed, it's 10%. And then the minimum possible percentage is 0%, because you could say all the people who love maths, there's enough there that they can be right-handed. But of course in our school, more than 10% of people love maths. I'd say it's more 80%, possibly 90%. Okay, so section B now, and this is where you have a chance to show off your style, impress the examiner with what you can do, but also make sure you have a go at all the questions and give it a good old go with your reasoning and your logic, and making sure it's easy to follow what you're doing. Question 8 is about door codes. How many door codes use only the digit 7? Well, only quadruple 7 would. The digits 117, probably the easiest way to see this is to write them all out. And then C, 1177 is there's actually 6 of them. Again, if you write them all out, that's probably the easiest way. So D, how many door codes start with 8? Well, you think about the numbers 8,000 to 8,999 inclusive. So that's 1,000 numbers that start with 8. And then do a similar thing with how many possible door codes are there. 0, 0, 0, 0 to quadruple 9 inclusive. So there are 10,000 codes overall. Number 9, we've got this operation. Take a moment just to look at their example and see if you know what they've done there before you continue. Part A, it's pretty simple, just getting used to the format of it. So it's 45 there. Simplify the two x and y ones. So you've got x squared minus x squared is 0. And then actually you've got x, y and yx, which is 0 as well. Which goes back to the thing I said about xy and yx being the same, because multiplication is commutative. Find 3 different numbers that equal 0. Well, the only way you're going to get that work is if y is 0. So you can have any value for x and z, but if y is 0, then x, y, z in brackets will equal 0. So any numbers but y got to be 0. And then the last bit, so it's 4 marks here, so well worth taking your time, laying it out neatly. Put it in brackets in the middle, so you know what you're doing, and then follow it through, and you get that the answer is 1. Question 10 is probably my favourite in the paper, but it's a good one here. Which tap delivers more water? Well, the one that takes the least amount of time, which is tap B. If both taps are running, well, if tap B alone takes 4 hours, and then you've got tap A coming in as well, it's going to take less than 4 hours, using your logic there. And then part C is the bit where you get a chance to really show what you can do. You can either invent an amount of water that the pool holds, make sure it's a multiple of 8 and 4, for example 32, and use that to work out the time, the rate each tap flows at. Or do what I did, which is give it a variable, P, and that's the number of litres to fill the pool. So then you get your rates of filling as P over 8 and P over 4. It's a bit like a speed, distance, time there. So the combined rate, by adding them together, is 3P over 8 litres per hour. So then the time to fill is the amount of water you need, P, divided by the rate, which is 3P over 8. Flip and times, cancel the P's, and it's 8/3 of an hour, which is 2 hours and 40 minutes. Now, of the two ways, it's probably more impressive to use a variable as the amount of water the pool holds, but I can imagine they would accept it if you said, let there be 32 litres of water in the pool. Question 11 is, you're not going to be able to work out 2 to the power of whatever it is, and actually they tell you it's not going to fit in your calculator, but they do give you a clue to start off with. So basically start off with the powers of 2 and look what they end with. And you'll see pretty soon there's a pattern. It goes 2, 4, 8, 6, 2, 4, 8, 6. So the repeating pattern is every 4th term. So what you do is you divide it by 4, and you get a remainder of 1, which means it is that one there, the same as 2 to the power of 1. So it ends in 2, but don't forget you've taken away 1 to make it into a prime number. So the Mersenne prime would end in 1. So that's the end of the paper. Remember, it's important you get through section A quickly but accurately, and then section B is your chance to kind of demonstrate a bit more of your style and show off, as it were, to the examiner.